So we are discussing about force method of analysis, right? Force method of analysis. Now, in the force method of analysis, we have seen that the method can be called as uh, flexibility method or method of consistent deformation. In the previous class, we have discussed, okay, or it can be also called as compatibility method, okay. So why this force method is called flexibility method, why it is also termed as compatibility method, we have discussed in the previous class. So basics of force method we understood in the previous class. Now today we will get into more detail about the force method and try to understand the steps involved in force method of analysis, okay. So you should one thing you should remember that while doing the analysis of structure using force method, you should be very comfortable, very much comfortable about calculation of deflection of structure at any particular point because of any load. Basically deflection of the determinate structure, rather I should say deflection of determinate structure at any particular point because of any load. It may be a point load, it may be a uniformly distributed load, or it may be a combination of uniformly distributed load or point load. So the deflection at a particular point you should be able to calculate. If you cannot calculate or find out the deflection at a particular point, you will not be able to apply the concept of force method, or you will not be able to find out the compatibility equation as such using the force method of analysis, okay. So one thing you should be very clear at this point, that deflection calculations are very important. Deflection calculations of structure, I think madam has discussed, Ankita madam has discussed all the deflection calculations using different methods, right? So you remember moment area theorem and conjugate beam method and energy method, and then I have also in the previous semester we have also discussed in strength of material about Macaulay's method. So I hope you remember all these things. So now you will have to remember the concept of finding out deflections using at least 1 2 3 different kinds of method, okay. So moment area theorem, have you studied moment area theorem? Anyone? Madam has explained, right? Moment area theorem and conjugate beam method. Are you listening or not? I don't know why you go so blank. Is it being discussed, moment area theorem? Can you hear me? Anyone? I don't know. Means there is no
Sir, yes,
response.
sir.
See, moment area
Yes, sir.
theorem you learned, right? See, if you say no sir, I did not know about moment area theorem, then discussion will go in different path. If you know moment area theorem, then discussion will go in different path. So you should respond to whatever I am asking, right? I don't know whether you are there with me or not. Means in every class I am seeing more and more the classes are going on. I see that people are not in the class. Maybe you are just switching on your mobile phone and not in the class. That's what is happening. So see if you do not understand, if you cannot understand something, then you must tell that sir, I did not understand this thing, then I should be able to explain you in a different way. But in this class what is happening, I am speaking in one way, and you don't respond. Whatever I ask you say, you don't say anything. So what is my assumption? I assume that you are understanding everything. So see, if you have not understood the force method concept, then you must say today that sir, I did not understand this part of the thing, then I can explain it again. Okay, anyway, so see, in the force method of analysis, or in the flexibility method of analysis, the point I wanted to emphasize again, that you must be very cautious, and you must be very much conversant with the calculation of deflection for any determinate structure under different kinds of load. Okay, so if you cannot find out the deflection, you will not be able to find out the compatibility equation at all, and if you cannot find out compatibility equation, you will not be able to solve the structure. Okay, so let us now go into little bit more detail about the force method or flexibility method of analysis. We have stopped here, right? Force method of analysis. So we have said that force method of analysis is also known as method of consistent deformation, and what we understood, that this uses equilibrium equations and compatibility conditions. Obviously it will have to use equilibrium equations as well as compatibility condition. So to determine the unknowns in statically indeterminate structure. So force method of analysis, one thing you must be clear here, that in case of a statically indeterminate structure, this should be applied. Okay, now you see, next point, where you must understand that in the force method of analysis, if you see what we have done, we have taken, in the previous class I have shown you an example of a prop cantilever, right? So where you have seen that in a prop cantilever, one end is cantilever end and the other end there is a prop. Okay, and in that case, if you remove the prop, then it is becoming a simple cantilever. So a simple cantilever is nothing but a determinate structure. Okay, and if you find out the deflection of that cantilever under any load at particular point, or the point where the prop is there, and then you remove all the loads from that cantilever and only apply the unknown force, that means the reaction force, as I have shown you in the previous class, that the reaction force at the prop end. Okay, so if you apply at the free end, or the position at the point where the prop is there, then you will get another one deflection equation. Okay, so from that, if you equate those two deflections, because at the point where the prop is there, you must understand that there should not be any deflection of the beam. So if there is no deflection, so under the external load without the prop and under the reaction force at the prop without any load acting on the structure, the sum of the two deflections must be equal to 0. So that is going to give you a compatibility equation, and from that equation you should be able to solve the unknown reaction at that point of the prop. Okay, so from this point you must try to remember one term, that in the force method of analysis, whatever unknown we are solving, what are the unknowns we are solving? I have explained it. So the unknowns whatever we are solving, they are nothing but the forces. You must understand. Okay, so see, that is the difference between the force method and displacement method. In the force method of analysis, all the unknowns are the forces, and the forces may be the external forces, that means external reaction forces, or the internal forces. And when you talk about the forces can be a reaction force or it may be moment, both. Okay, so the unknowns in the force method, so you must understand that whatever the unknowns in the force method, those unknowns are called redundant forces. This is a very important term, these redundant forces. Okay, so these redundant forces, whatever the unknowns you are trying to solve in the force method of using the force method of analysis, those will be termed as redundant forces. Okay, this is a very important term. Multiple times you will see this redundance, this term will come in your structural analysis course. Okay, so redundants are nothing but redundant forces means the number of unknown forces, and forces means again you should understand either the reaction forces or the moments, and it may be the external reaction and moments or the internal reaction and moments in any member of the structure. So those kind of forces will be called as redundant forces. Okay, so a redundant force, as I have mentioned just now, you see it is being explained here that a redundant force can be an external support reaction force, but obviously it can be external support reaction force. So a redundant force, you see, a redundant force can be external support reaction force. So it can be external support reaction force, and or it can be also internal member force. Okay, so internal member force, when we will be discussing one or two problems, then you will be able to understand. First we will be starting with external support reaction force, then also we will be trying to understand what is internal member force, which is making a structure indeterminate. Okay, so if a redundant force, the redundant force which can be external support reaction or internal member force, if you remove it from the structure, so that means if you remember in the previous class whatever I have discussed, there I am showing you one cantilever beam which is having a prop at its one end. So that's the propped cantilever. So that propped end, that prop was giving that cantilever beam 1 degree of indeterminacy, right? So that 1 degree of indeterminacy, that prop end, the redundant in that case is the reaction at the prop end. Okay, and that redundant force, that reaction at the prop end, is basically the external support reaction force. Okay, it is not internal member force, it is external support reaction force. And you see, when you remove that force, that means what? Which force? That redundant force from the structure. So a redundant force, when it is removed from the structure, so what we have seen in case of the prop cantilever? So if you remove the redundant force from the structure, you will get one structure which is basically a cantilever, simple cantilever beam, which is a stable structure and it is a determinate structure. So once you remove the redundants from the structure, and after removing the redundant, if you get a structure which is stable enough, it should not be unstable. Okay, so considering the structure stability point of view, if you remove the redundants from the structure, after that whatever structure you will be getting, that structure will be called as a primary structure. So a redundant can be an external support reaction force or an internal member force which is removed from the structure, and that will not cause any instability. So this is very important. So you are thinking that some redundants are here, and then you remove them, and after removing the redundant you see the structure is not remaining stable, so you cannot tell those kind of internal or external forces as redundant forces. Okay, so if you remove such kind of forces, from the structure, after removing those redundant force, if you are getting a stable structure, that structure will be called as a primary structure. Okay, that structure will be called as what structure? Primary structure. Okay, so you see, after removing these redundants, this force method will help you to formulate a set of compatibility equations. And I have explained you what are the compatibility equations. Depending on the number of the redundant forces in the structure. So that means what? That means the number of redundant force you are having in the structure, which you are removing from the structure, depending on the removal of the redundant forces or depending on the number of the redundant forces, you are going to get that many number of compatibility equations. So if you have one redundant, you are going to have one compatibility equation. If you are having two redundants, you are going to have two compatibility equations. If you are having three redundants, you are going to have three compatibility equations. So let's assume that if you are having three redundants in a structure. So if you are having three redundants in a structure, so you know three redundants means three unknown either external reaction forces, support reaction forces, or internal member forces. So from after removal of those three redundants, you will be getting three compatibility equations. And if you solve, and those three compatibility equations will be just like your simultaneous equation. So if you solve the equations, simultaneously, then you are going to get the value of the redundant. So basically what you will have to do, you will have to solve the compatibility equations simultaneously. So basically this compatibility equations, that is what finally you will have to do for solving the structure. So the compatibility equations require solution just like the solution of the simultaneous equation, and from that you should be able to determine the magnitude of the redundant forces. Sorry. So from that you should be able to determine the magnitude of the redundant forces. This is very, very important. Okay. So I think you should now understand what is redundant force. You must have understood what is redundant force and what is the primary structure and how you are getting the compatibility equation. Okay. So once the redundant forces are known, if you know the redundant forces, then what will happen? Once you know all the forces, then the structure becomes determinate and can be analyzed completely using the conditions of equilibrium. Indeterminate means what? The number of reaction components either in the form of internal or external reaction components, you don't know those reaction components, but when you solve for the redundants using the compatibility equation, in that case what will happen? You know all the unknown forces in the structure. Once you know all the unknown forces in the structure, then what will happen? You will be able to now apply the equations of equilibrium and or the conditions of equilibrium, and using the conditions of equilibrium you should be able to solve the structure. Okay. So once the redundant forces are known, if you know the redundant forces, after that you should be able to analyze the structure completely. You should be able to analyze the structure completely using what? Using the conditions of equilibrium. So if you use the conditions of equilibrium, you should be able to solve the structure. Up to this point, do you have any doubt? So should I ask some question now? So let me ask one or two questions. See, what is basically what is the basic difference between the force method and displacement method? Can anyone tell? Force method and displacement method. Force method and displacement method. Praman Yogi, can you tell? Praman Yogi, are you listening? Praman Yogi. Krishanu Nag, are you there? Krishanu Nag? Krishanu Nag, are you there? Priyanka Bharti, are you there? Priyanka Bharti, are you there?
सर आपकी आवाज बहुत कम आ रही है, बहुत धीमी आ रही है।
तो आपने बताया नहीं शुरू में धीमे आ रही है तो why are you not telling while at the beginning of the lecture?
सर अब
Now is it okay?
यस सर।
सी इतना धीमे आ रहा है, सब लोग किसी को सुनाई नहीं दे रहा है मेरा आवाज?
आ रहा है सर।
Then what is the problem? Then you should tell that you are not able to listen me. I'm multiple times I'm asking that you are whether you are able to listen or not, listen or not.
Sir,
Yes.
column in force method, sir, method of consistent deformation will be there, and in displacement, slope deflection method will be there.
See, you should not say slope deflection. See, in force method of analysis, what will happen? Your unknowns are the redundant forces. Okay.
Yes, sir.
So the unknowns, whatever you will have to solve, they are the forces. Whether in case of displacement method, the unknowns you will have to solve are the displacements. That is the basic difference. Okay. Is it okay? Now tell me, why force method is called flexibility method? Who can tell? Why force method is called flexibility method? See, these are the questions being asked, very simple questions which are being asked in interviews. And I am explaining this thing multiple times. You are not, if you are not able to understand, then you should tell. Priyanka Bharti, now can you listen?
Sir, because flexibility appears in the equation of a compatibility, sir.
No, it's not flexibility not appearing in the equation. See, the thing is I have explained you what is flexibility. What is
Forces
flexibility?
are unknown, sir. Means
Flexibility is used in the force method of
कंसिस्टेंसी
analysis.
डिफॉर्मेशन सर।
Yes, flexibility is what? Flexibility. So stiffness and flexibility. There is a difference between flexibility and stiffness. I have explained in the previous class. So flexibility is what? Flexibility is deformation due to unit force, right? Flexibility is the deformation due to unit force. And in the force method, what is the unknown? Force method, the unknown is the force. So if you find out the deformation under unit force, you should be able to find out the deformation under the unknown force, right? So once you know the deformation under the unknown force, from that only you are getting the compatibility equation, and that is why the force method will be termed as flexibility method. Okay. So in case of flexibility method, you see, in case of flexibility method, what you are doing, you are finding out the displacement, right? And displacement under unit load, and this displacement under unit load, once you find out the unknown amount of reaction or internal reaction, whatever you say, or internal forces, whatever you say, under that unknown thing, that is the redundant force, as we have understood just now, under the redundant force you should be able to find out the deformation. Once you find out the deformation under the redundant force, you should be able to formulate the compatibility equation, and that is why the force method of analysis is called the flexibility method also. Okay. Now let us try to understand, taking a very simple structure. Okay. So let's say, let me let us keep it a problem. So let's say, can you see this beam? Actual structure, whatever is drawn over here, can you see this? So
Yes,
tell
sir.
me, So what is this kind of structure? What is the structure? Is it a beam or it is a column?
Beam, sir.
It is a beam, absolutely correct. So what are the supports given in this beam? Just concentrate on this structure, this actual structure. What are the supports given in this beam?
Roller support and
Roller support. So roller support is at where? Which point
B,
there is
sir.
B,
B point, sir.
B point.
B point.
And is there any other support on this structure?
So A, sir. A point.
A.
Fixed support,
So
sir.
A is
A.
which kind of support?
Fixed support.
Fixed support.
Fixed.
Absolutely correct. Yes. And what is the load acting on the structure?
P, sir.
P. Which kind of load that P is?
Point load.
So point load, sir.
Yes, absolutely correct. Point load. So you now tell me, when it is a vertical load P acting on the structure, how many unknowns you need to solve for this structure? So first thing you see, first you will have to determine for any kind of indeterminate structural analysis that what are the number of indeterminacy, what is the number of indeterminacy, or what are the number of indeterminacies. Okay. So in this structure, now you tell me, this actual structure, how many reactions you need to find out? You tell me, how many reactions you need to find out?
Sir, 4 reactions.
5, sir. 5.
4 or 5? Who have said
4, sir.
5?
4.
Who have said 5? Can you tell me what are those 5 reactions? Okay. Who have said 4? Tell me what are those 4 reactions?
Sir, at fixed point A point, sir, 3, sir. One moment, 2, one horizontal and one vertical,
Correct.
and B position, sir, roller support. That is the one vertical, sir.
Correct. So at A, absolutely correct. At A, you see this is a fixed support. So how many unknown reactions component will be there? There will be a vertical reaction at this point, there will be horizontal reaction at this point, and there will be a moment at this point, right? And at B, it's a roller support, so there will not be any moment, there will not be any horizontal reaction, only the reaction will be in the vertical direction. So you see, there will be 4 unknown reaction components, right? Now you see, from the structural view, if you see the structure as a whole, then you see there is no horizontal load is acting on the structure. In this structure, there is no horizontal load is acting. So you see, what you can say, as there is no horizontal load is acting on the structure, you can say only the unknown components are 3. Okay, or you can say unknown components are 4, considering the horizontal reaction also. So see, 2a you should perceive this equation, because many cases you may get confused. See, in this structure, in this actual structure, you see there is no horizontal component of force is acting, there is no horizontal external load is acting, right? So there will not be any horizontal reaction coming at this point A, that you should must be careful about. Okay, and considering that, you see your number of unknowns will be in that case 3. However, you should understand there that when you are not considering that there is no horizontal reaction will be coming at this point A, then your available equation of equilibrium will be also 2. Okay, or in other way, if you consider the horizontal reaction component at A for generic case of generic kind of cases, so in that case what you will have? You will have one vertical reaction over here, one horizontal reaction over here, one moment over here, and another one vertical reaction over here. Okay, so 4 unknown reaction components you have. And how many equations of equilibrium you have? You have how many equations of equilibrium? Equations of equilibrium, tell me.
3 equation of equilibrium,
3
sir.
equation of equilibrium, yes. So 4 unknowns, 3 equations of equilibrium. So can you solve this structure using the equations of equilibrium or equations of static? 4
No, sir.
unknowns, 3 equations, so you cannot solve. So what you require? You require another one equation, right? And that another one equation will be coming, that another one equation will be coming from the equation of compatibility using the force method. Okay. Now what you have to do? If you remember, just few minutes back I was telling you that redundant force. Now you tell me, in this structure, if you want to solve this structure, what can be the redundant force? What can be the redundant force? Tell me. So how many unknowns? How many unknowns you have to solve? 4 unknowns are there, right? 3 equations of equilibrium are there. So how many degree of indeterminacy? 4 minus 3 is equal to 1. So you have only one unknown. So which is the unknown you will have to solve? The unknown you want to solve, that will be your redundant force, right? Now you tell me which one will be your redundant force in this actual structure. Which one will be your redundant force? Tell me. Bolo. What is the redundant force? Just few minutes back I was explaining, right? What is redundant force? Redundant force means, you see, what is redundant? What is redundant force? See? A
Unknown, sir.
Yes, a redundant force. What is redundant? A redundant force is nothing but an external support reaction force or an internal member force, right? Which can be removed from the structure. When removed from the structure, that force after removal from the structure will not cause any instability of the structure, isn't it? Isn't it? So you see, redundant force in this structure. So in this structure, if you want to consider the redundant, what are the forces? See, you should be able to tell it. Very simple. So here is one force, okay, and then there is another one horizontal component force here. Then you have another one vertical force over here. So another one vertical force, let's say. If you do not get the concept, then you will not be able to solve the problems. You see, here is another one force. Which one? Another one. Which one will come? Bolo? So
Moment, sir.
Moment. Yes, moment. So let me take this arrow and just put it over here. So let's say this kind of moment is there. Just I am putting it like this. Okay. So this is a moment over here. So one unknown, two unknown, third unknown, this is fourth unknown, right? Now you tell me what is the which will be the redundant force. So what is redundant force? Redundant force is the unknown force, first thing. So you see, redundant force can be external support reaction force or an internal member force. So this support reaction, you see, this support reaction, let's say at this point, if I remove this support reaction, then what will happen? If I remove this support reaction, that means what will happen? That means if I remove this redundant force support reaction from the structure, that means what? How can this force be removed from the structure? Only if I remove this support from this position, right? If I remove this support from this position, then actually what I am doing, I am actually removing this reaction force from this structure. Once I remove this support from this structure, what will happen? You see the next point. So you are getting from the actual structure, if you just see it from the actual structure, see what you do, you remove this. If you remove this, that means what you are doing? You are removing the redundant. What is the redundant in this case? Redundant is in this case redundant is nothing but the reaction at the prop. So if you remove this redundant, then you see after removal of this redundant, what is the definition of this? So what force you have removed? You have removed an external support reaction, isn't it? It is the external support reaction you had. So you have removed an external support reaction, which after removal from the structure will not cause any instability of the structure. So once you remove this redundant from the structure, once you remove this force from here, what will happen? After removal of this force from here, you see what will happen? This structure will become something like this, right? It will become this one, right? So once you get this structure, you see what you are getting. See, now you have one reaction over here, then you have one horizontal reaction over here, and you have one moment over here, right? And you see you have removed this prop, or you have removed this roller support from the structure. After removal of this support from the structure, you see this structure remains stable, because you see what is happening to this structure. After removal of this prop, or after removal of this roller support from the structure, which necessarily is this redundant force. After removal of this redundant force, what is this redundant force basically? This is nothing but the reaction at the B. This one I have removed, right? So once I have removed it, necessarily this structure remains a stable structure, and you see this has become now a what? This has now become a simple supported beam. It has become a simple supported beam now after removal of this point load. What it has become? It has become a simple supported beam or something else. See, if in the previous class also you got confused, then you only answered. Now you are not able to tell again. What is this structure? Can anyone? You cannot say what is this structure.
Cantilever.
So why is so much time is taking? It's a cantilever beam. So after removal of this redundant, you see it is becoming a cantilever beam, and cantilever beam is a stable structure, right? So after removal of the redundant, what the structure which is basically which needs to be a stable structure, that structure will be terming as primary structure. I have explained you what is the primary structure. Now with example you should be able to understand what is the primary structure. Is it clear now? So you see in the primary structure now you see there is no reaction at this point now, because there is no support, because what you have done, you have removed the redundant force. So after removal of the redundant force, the structure is remaining stable, and after that in that primary structure what you should do? Under the external load. So what is the external load acting over here? This is a point load. So under this external load, you find out what is the deflection at this point. Okay. So delta BP means what? The deflection at the point B. You see, this is your point A, this is your point B, and this is your force P. So because of this load P, what is the deflection at this point B? You find out. Okay, because you must understand, now you have removed the redundant from the structure, and after that you have got a stable structure. Okay, so at this point you find out what is the deflection. So that is what I was telling you, that you must be well conversant with the deflection calculation of determinate structure before solving the structure using force method of analysis or flexibility method of analysis. If you do not understand that if you do not remember what will be the deflection, or if you cannot calculate the deflection at this point because of this load P, then you will not be able to form the compatibility equation at all, right? So you should be very, very carefully learning those methods, whatever madam has discussed, okay? Or even I have also discussed in your previous semester in very, very minute detail that Macaulay method, using Macaulay method, finding out the deflections at different point of the structure for a determinate structure, okay? Now once you find out this delta BP, that means what is delta BP? Delta BP is nothing but the deflection at B due to this load P. So see, this P may be a point load, this P may be a uniformly distributed load, this P may be a uniformly varying load, or this P may be a multiple combination of point load and your UDL, whatever it may be. So you will have to find out the deflection at the position from where you have removed the redundant. Is it clear? So this is your primary structure. So you should be very clear about primary structure now, and at the primary structure you should be finding out the deflection. Now next point will be what? You will have to find out. So only finding out the deflection, you will not be able to find out the compatibility condition, because at that point from where you have removed the redundant, at that point you will have to apply the condition of compatibility. So to apply the condition of compatibility, what you will have to do, now you see on the primary structure, please understand very carefully, on the primary structure. Now what is the primary structure? You have already told me that primary structure in this case is nothing but a cantilever beam. So this is your primary structure. Now you take that primary structure again. So the primary structure which you have analyzed and found out the deflection under the external load P, you take the same primary structure. You see, we have not taken any other thing. We have taken the same primary structure, and on that primary structure you remove, from that primary structure you remove all the external load component. You see, in this figure C, you can see that no external loading is being applied on this structure. And what you do, you find out what is the if you apply the redundant over here, and you don't know what is the value of the redundant, right? So instead of applying the redundant force, because you see, if you don't know the value of the redundant, then what you have to do, you will have to apply one unit force. So applying the redundant equal to 1, so redundant XB of unit load. So considering the redundant's value is 1, okay, considering it as a unity 1, you apply it at the same point from where you have removed that redundant, okay, and on that primary structure you find out the deflection at the same point because of that redundant unit load, Is it clear? And you should see in this point, you should be very, very carefully observing that you are taking the same primary structure, however without any external load being applied on the structure. See, in this case C, you see there is no P, in this C, you see there is no external load P is acting on this structure, okay. Is it clear? Now once you find out this, now you can find out under this unit load what will be the deflection at this point, okay. Now you see that compatibility condition will come into picture. So you have found out because of this load what is the deflection at this point, because of this redundant which is of unity, you have found out this deflection. But is your redundant force is unity? No. That redundant force will be having some value RB, let's say, and which is unknown. So redundant in this case is the reaction at the prop or reaction at the roller support, that is RB. So because of unit load you have found out what is the deflection. So for one unit load, if the deflection is that much, you should be able to find out because of RB load what what will be the deflection at this point. So if you can find out the deflection because of the RB load at this point, and if you can find out the deflection at this point because of this P load, then you should be able to equate those two values of the equation. Okay, so what you'll have to do, you'll have to equate those two values. See this one, delta BP, that is the deflection at point B because of P, and the deflection at B because of that XB. XB is what? That unit redundant load. Okay, and RB is being multiplied with that. So sum of those two must be equal to 0. Because why? Because at this point in structure, there should not be any deflection coming. So that is actually your compatibility equation. So see, you know this delta BP, you know this delta BB. So what you can find out? You should be able to find out RB. So once you know this thing, so what will be happening? So you know this moment, sorry, you know this load now. Now you should be able to apply the condition of equilibrium, because you see now your RB is known to you. So once you know this RB, you should be very easily able to find out the reaction components at the other points. So you should be able to find out this, you should be able to find out this, you should be able to find out this, because you know the conditions of equilibrium, and you should be able to apply the conditions of equilibrium at this point. Okay, so considering this, I should stop here. There is another one point I will discuss in the next class, because this primary structure from the previous structure, the primary structure whatever I have shown you, that primary structure can be also taken in an alternative way. I will explain this alternative way of considering this primary structure in the next class. Okay, so hopefully you have understood it. I'll give you these details in the next class, because you should be remembering these values of the deflections very carefully. Otherwise you will not be able to solve the structure using force method or compatibility method of compatibility method or flexibility method of analysis. Okay, so let me stop here today. But before stopping, I would like to announce that you have seen that class test will be happening from 15th to 18th, right? 15th to 18th. So, or 22nd, your will be finishing between 15th to 18th. Okay, so what will be the syllabus of the class test? That is another one question. So let me give you the syllabus. So just see this. Syllabus, 5th semester. CPC 503, right? 503. Yes, structural analysis. Okay, so you see, syllabus will be your module 1, full module 1. So basic structural analysis concepts. So determinacy, indeterminacy, static indeterminacy, kinematic indeterminacy, everything will be there for different kinds of structure. Then theorem of maximum potential energy, Betty's law, Castigliano's theorem, virtual work, all these things will be there. Along with that, there will be module 2, that is analysis of determinate structure only up to this, only up to the portal frame, no 3-hinged arches and cables. Okay, so basically we will be taking test on these two parts, that distinguish between stable, unstable, statically determinate, indeterminate structure. So your understanding will be tested for these two course outcomes, that is distinguish between stable, unstable, statically indeterminate, determinate structures, and apply equations of equilibrium to structure and compute reactions. Okay, so only will be taking up to portal frames. Okay, in the next class test we will be taking 3-hinged arches and cables. Okay, so you need not to worry about 3-hinged arches, cables for the class test, but whatever I have taught you, you please go through them very carefully for 3-hinged arch and cables also, not for this class test, but for the next class test also. Okay, so is it clear? Do you have any doubt?
सर न्यूमेरिकल भी रहेगा सर?
Yes, numerical will be there. Class test questions will be something like 5 marks kind of plain objective. Okay, and then there will be 4 questions of 5 marks. Okay, 5 into 4 20, there will be 25 marks question.
सर
But
न्यूमेरिकल में ऑप्शन रहेगा कि नहीं सर?
yes, numericals, in the numericals also there will be options. Okay, numericals also there will be options. I have sent out a mail yesterday, if you see, but you will have to work out the numerical in your paper. Okay, so usko solve karna hai, and random basis or using Google Meet will ask you to switch on your video and will check that whether you are solving the problem your own or not. जस्ट इधर उधर से व्हाट्सअप करके पूछ लिया कि ये वैल्यू बता दो और बस वो डाल दिया और क्लास टेस्ट में 25 मिल गया, ये नहीं चाहिए मेरे को. सो एवरी क्लास टेस्ट, इट्स नॉट फॉर स्ट्रक्चरल एनालिसिस, एवरी क्लास टेस्ट एनी टीचर will be asking you for the workout of the problem. Whatever you are doing on the paper, that will be asked. Okay, on random basis.
सर गूगल मीट ऑन करके रखना होगा ना?
Google Meet on करके रखना है, but we'll see the technical feasibility of that. In some cases what may happen, if you are using your mobile phone, in that case what may happen, if you are opening that Google form, because you'll have to open the Google form for solving the problem. Okay,
यस सर,
At that
रिफ्रेश हो
time,
जाता है
there-
सर.
at that time it may happen that Google Meet may be getting closed. Okay, so it will not happen if you are using laptop, but if you are using your mobile phone, then it may happen. Okay, so we are not too much concentrating on Google Meet, but you must be honest in your answering things. That is very important. Okay, so you should try your own. Don't think about marks at this point. You should learn things. You should try to attempt questions your own. Okay, so you should work out the problems on the copy. On random basis we will ask you. किसी को भी पूछ सकते हैं, और अगर फाइंड किया गया कि वो 25 में 25 मार्क्स में 25 मिला एंड ही हैज नॉट डन एनी कैलकुलेशन इन द कॉपी, देन surely he will be getting only 5 marks or less than 5 marks. We are not going to give any marks in that case. So you should be very honest in your answering the paper. Whatever you can do it your own, you should do it. Okay, and the second thing is, this time only you will be getting questions just before 2 minutes of the class test, and you will have to complete it and submit it within 1 hour only. Okay, after 1 hour, after the test is over, your submission page will be completely closed. Okay, so there will not be any option given.
Some more time, sir.
सर समटाइम कनेक्टिविटी इज लो
15
सर.
or 20 minutes more,
See,
sir.
in 1 hour it is enough. 1 hour it is enough. Okay, questions
सर
will be
कनेक्टिविटी
not-
इशू भी रहता है सर कभी कभी.
questions can be
Yes, sir.
solved
That's why
in-
we are telling that. After you can increase by 15 minutes, sir. It is. We are not
No.
asking for anything.
See, we can increase by 5 minutes. Okay, but you should try to solve it within 1 hour. Okay, see, it's not that connectivity problem will be every time, and there will be every time it cannot be submitted at that point in time. Okay, so see, case to case basis we can take it. Okay, maybe we'll be opening it for another, so that in that case you will tell, I am not getting connectivity, other person will tell, I am not getting connectivity. I cannot individually open for everyone, right? I'll have to close it at some point in time. Okay, so the question,
तो 5 मिनट सर एक्स्ट्रा ही रहने दीजिए.
5 मिनट्स मिलेगा, ऐसे चिंता मत कीजिए. ठीक है, 5 मिनट्स रहेगा. इट्स नॉट दैट 10 बजे मतलब 10 बजे एकदम बंद कर दिया, ऐसे नहीं होगा. ठीक है, 5 मिनट्स विल गेट एक्स्ट्रा. डोंट वरी अबाउट दैट. वी आर नॉट हियर टू किल योर मार्क्स, राइट? we want to give you marks after you learn properly. That is the point. Okay, so it's not that we are trying to kill your marks. Okay, so don't worry about that, but you should study well and then attempt the test. That is what is my point. Okay, please everyone. Okay, so let me take the attendance for today. If you have any doubt, okay, you ask. Okay, for any teacher, if you have any doubt about your question, this thing and all, you please ask individual class teachers. Okay, so thank you. Okay.